let me tell you one more thing, which is actually absolutely critical and very important to understand, for utility over lotteries. Okay, so if you have this capital U function, remember capital U, the domain is set of all lotteries or set of all random variables. Okay, and if you have this small u function, which is a corresponding Bernoulli utility function over wealth levels. Is that okay? So if I take any monotonic transformation of capital U, will that also represent, so please understand the question, that I want to represent the preference of this particular individual over lotteries. Okay, so this is a utility function which will represent the preference of this individual over lotteries. Now what I'm doing is this, I am applying an increasing function. So consider any strictly increasing function or a monotonic function. Okay, and let's say this function is f from R to R, which is strictly increasing. Okay, now consider f of capital U. Will that also represent the preference of this consumer over space of all lotteries? Suppose you have two lotteries, x and x prime. Okay, notice that capital U of x and capital U of x prime, is greater than if and only if f of u of x is greater than or equal to f of u of x prime. That's a proof. It will always work. So any increasing transformation of the capital U function, okay, please, very important, any increasing transformation of a capital U function will give you again a utility representation of the preferences over the lotteries. Okay, but let's just, so be little careful about, let's say if we try to apply f to small u, okay, and then consider expected value of this.
You can change the risk over it and another thing.
Will that work? Yeah, so suppose we have,
I have an example.
You do x square.
Yeah.
Transformation, but it will change the risk behavior.
Absolutely. So this is something which will not work. Okay, I mean, any f, I mean, if I just take small u, apply small f to it, okay, and then take the expected value of f of u and say that let's consider this as the representation over the lotteries, then things may change. So like for example ux is root x, it's a risk averse individual. Suppose f is x squared, okay, f or f u is u square, basically whatever. Okay, now if you apply f of u will be square of root x, which is x. Now you can see that, if you apply f to u and then consider the expected utility, then now you are actually looking at a person who is risk neutral, even though the individual was actually risk averse. So in this case, not every increasing transformation will work. However, linear or affine transformations will work. Okay, so I mean, it's actually this is a word, so I mean, just if you consider v, which is a times u plus b, where a is positive, that will work. Okay, now so basically if you want to transform u, small u, okay, and then you want to preserve the expected utility form, okay, you want to also preserve the expected utility form, then these are the transformations which will work. Okay, suppose you are comparing x and x prime. Okay, what is the small u of, sorry, what is the capital U of x? It is expected utility of x, right? And suppose it is greater than or equal to capital U x prime, which is expected utility of x prime. Now I'm going to show that if instead of u you use v, this inequality will be preserved. So basically you will still rank lottery x over x prime. Is that okay? Fine. So let's show this. So let me call this capital Vx, which is expected v of x, right? Okay, and what is expected v of x? It is expected value of a u x plus b, right?
Yes.
Okay, which is what? A times expected u x plus b because of linearity. Okay, and what is this? This is a u x plus b, right? Which is greater than or equal to a u x prime plus b, and this is nothing but, you just have to reverse the steps. This is definitely, yeah, so if you want, you can write it like this: e v x prime, okay, which is the same as capital V x prime. So you can see that this transformation will actually preserve the expected utility form. So you can actually apply the expected utility on V. It will rank the lotteries in exactly the same way as the original U.